Hello and welcome back to Spark Coding. In this video, we will solve our next question of Leetcode, that is sort the matrix diagonally. The question number is 1329. You can find the question from the problems on Leetcode page. Okay, so let us see what is the question. We have given a matrix and we have to sort the matrix diagonal wise. Here is the example. Let us see this example. We have a matrix 3 3 1 1. Then 2 2 1 2, 2 2 1 2, and then 1 1 1 2, 1 1 1 2. So we have to sort this matrix diagonal wise. So if we see, this is my first diagonal, this is my second diagonal, this is my third diagonal, this is my fourth diagonal, this is my fifth diagonal, and this is my sixth diagonal. Okay. So if I sort this, I am sorting the first diagonal, just 1. So I will just get 1 here. Then I will sort the second diagonal. So output will come 1 and then here 2. And I will sort the third diagonal, that is 3 2 1 into 1, 2, 3. And I will sort the fourth diagonal, that is 3 1 2 into 1 2 3 again, 1, 2, and here 3. I will sort the fifth diagonal, and here is only 1 2, so it is already sorted. I will just write 1 2, and then the sixth diagonal, that is just 1, so it will just come here 1. So this way we have to sort the matrix diagonally wise. We all know in Python we represent matrix as a nested list. So let us see how it will be represented in matrix form, in nested list form. So I am taking the same example here again, 3 3 1 1, then 2 2 1 2, then 1 1 1 2. If I think about it, how it will be represented in nested list, so it will be something like this: 3 3 1 1. This will be my first nested list, and my second list will be 2 2 1 2, and the third list will be 1 1 1 2. So what will happen if I have to access this 2? I have to first access the first index list, and then inside that I have to access this 2. It is also present on first index. So basically I have to access it using 1 1 indexes. The first index, that is my row, and second index, it is my column. You can think of it like that. Okay, if I want to access 2, what will be the answer? The row is 1 and my column is 3, because list index start from 0. So this is my 0th row, this is my 0th row, this is my first row, and this is my second row. Similarly, if I think about column, this is my 0th column, this is my first column, this is my second column, and this is my third column. Let's say if you want to access these two, last two, what will be its indexes? So I have to access using 2, that is the row, and then column, that is 3, 2, 3. Let us see what will happen for the row, for all the diagonals which we have to capture. Okay, I am writing the same question again: 3 3 1 2, 3 3 1 1, and 2 2 1 2, then 1 1 1 2. Now I am writing it diagonally wise. Okay. The first diagonal which we want is 1, so its index is, we have just seen it, that is 2, 0. That is the second row and first column. Third row and first column. If you want the second diagonal, that is 2 1, let me first write all the indexes: 0 0 0 1, 0 2 0 3, 1 0 1 1 1 2 1 3, 2 0 2 1 2 2 and 2 3. So first we have already done first diagonal. Second diagonal we will have 1 0, and then 2, 1. The third diagonal will be this one, 0, 0, 1, 1, and then 2, 2. The fourth diagonal will be something like this. So this will become 0, 1, 1, 2, and then 2, 3. The fifth diagonal will be something like this. This will become 0, 2, and 1, 3. And the last diagonal will be just 1, and its index is 0, 3. This is my first diagonal. This is my second, third, fourth, fifth, and sixth. Okay, if we look at the diagonal indices individually, we can find some pattern. The pattern is, if we subtract this is my row number, this is my column number, we get some constant value. This constant value will be same for all that diagonal values. 1 minus 0 is 1, 2 minus 1 is 1. Let's take another example. 0, 2, the output is minus 2, and 1, 3, the subtraction will give me minus 2. So this is the logic for primary diagonal values. All the primary diagonal values have same logic. If we subtract row with column, we will get some constant value that will be same for all that diagonal values. Let us check the third diagonal. 0 minus 0 is 0, 1 minus 1 is 1, 2 minus 2 is 1 minus 1 is 0, and 2 minus 2 is 0. So this is the logic we can see for the diagonal. Now what we have to do, we have to store these diagonal values in some data structure, let's say dictionary or list, it's up to you. And after storing this, we can sort these diagonal values individually. Let us say, if I take another example, if I take my first diagonal, this is just 1, and its key will be 2 minus 0, that is 2. I am storing it in a data in a dictionary. Next diagonal, the second diagonal, will have the constant value, that is 1 minus 0, that is 1, and it will contain its value, that is 2, 1. We will sort it using Python inbuilt sort method, and we will check how to do that afterwards. The next diagonal will have the constant value 0, because 0 minus 0 is 0, 1 minus 1 is also 0, and it will contain values 3, 2, 1. We can sort this value afterwards. The next diagonal will have constant value, that is 0 minus 1, that is minus 1, and it will contain values 3, 1, 2. The next diagonal will have 0 minus 2, that is minus 2. It will contain value 1, 2. And my next diagonal is 0 minus 3, that is minus 3, and it will contain just value 1. I am storing it in a dictionary, and we will look it out how to sort it afterwards. You can just iterate through the dictionary keys and sort it out. But what will be its use? Let us see that. Now we just have to iterate over the matrix. Let's say I am iterating from here. I know my row is 0 and my column is 0. If I subtract this, I will get my first value from the dictionary, that is 0 minus 0. I have to check for the key 0, that means here, and I have to take the sorted value first, that is 1. Eventually this will sort it, so it will become 1, 2, 3. So I will just take first value and write it here. Instead of 3, it will become 1. Again, the pointer will come to this value, that is 0, 1. So I will check which index, which key it belongs to. So 0 minus 1 is minus 1. So I know which diagonal it belongs to, that is this one. Eventually this will also be sorted in order. So it will also be 1, 2, 3. I will just take the first value and put it here. So this is the approach. Let us see how we can code it out. Okay. First we need to iterate over rows and columns. So first we need rows and column values. So I am writing m comma n. M will be my rows, so len of mat, and L will be my columns, number of columns, so it will be len of mat of 0. So I am just taking the length of first column. Next I need to create a dictionary which will contain all those diagonals, all these diagonals. We can see that all these diagonals have list into them. So we can just, instead of dictionary, we can create a default dictionary with list as a parameter. If you don't know how default dictionary works, let me show you once. Let me open my Python shell. I am importing default dictionary from collection. From collections, import default dict. So I have imported default dictionary, and I need to create some variable. Let's say di is equal to default dict. Now we need to pass one argument here, that is the constructor of which we need to create default dictionary on. Basically default dictionary means it will have some key and the value will be default empty thing. Let's say I need to create default integer values. So what will happen? There will be some keys, for example x, and its default value will be 0. Let us take a look. I need to create di of, let's suppose a. We can see its value is 0. If I print di, we can see the key is a and the default value is 0. Similarly, in this scenario, in this example, we have to create a default dictionary of list. So I need to create a default dictionary of list. So instead of int constructor, I have to call list constructor. Now let us check if I am getting the right output. I am just writing di of 0 and I am getting empty list. And if I print di of 0 append 5, it will just append it to a list. Now I don't need to concern myself with if it is list is empty, then we have to create empty list, then we have to append. Instead of doing that, I have just created a default dictionary. We can just append directly to it. Okay, I am putting my dictionary name as di, and in Leetcode we don't have to import those modules. Those are already imported, so we just have to call its methods, default x, and I need to call list. Now we need to iterate for the matrix. So I am creating for x in range. First I have to pass the rows, number of rows, that is m. For y in range, number of columns, that is n. Now we need to figure out our logic. We need to write our logic. Logic was pretty simple, pretty easy. We just need to subtract those values, row and column, and this will give me key of the dictionary. 0 minus 0 is 0, and we need to append the value into our list. So I just need to put di of x minus y. This will give me 0. This will be a key into my dictionary, and we have created a default dictionary, so I can directly append it to it, and the value will be mat of x of y. So this will give me this dictionary. Now we have created this whole dictionary. Now we need to sort those dictionary values. For that I am writing another for loop, for key comma while in di.items. So this will just give me key and value of the dictionary. Now I just need to write val.sort. So this will sort all my values. Now the next part, we have to update the matrix according to the values in the dictionary. Basically we need to, now this is all sorted, so I am getting this output 1 2, then 1 2 3, 1 2 3, then 1 2 again, and 1 here. Now we again need to iterate over the whole matrix, and when we are getting the values when we are getting the keys of the diagonal, that is 0 minus 0 is 0, we will just have to get the first value and put it into matrix. So let us see how we can do that. For again I need to create for x in range of m, for y in range of n, and directly I have to put it into matrix. So mat of x y is equal to. Now here is the important thing. Where I am getting the value? I am getting the value from dictionary keys. So I first have to minus this x and y, 0 minus 0 or 0 minus 1 or 0 minus 2 depending on the iteration, and I have to find that key into the dictionary, and we have that value here. So I just have to use pop method for this, such that the next time I come again for the diagonal, this value will be removed and I will directly get the next value. So I am writing it something like this. So it will be di of x minus y, and what I have to pop? I have to pop the first value. Why I am writing pop? Because the next time I come to this key again, so this value will be removed and I will directly get the next value. And this will help me maintain the diagonal values. So let's try returning the matrix. Let us check if it is working or not. Okay, it is working fine. Because the constraint was small, we can use this method. Let us try to submit this. Okay, it is accepting all the test cases, but this is not a good practice. When we are writing pop of 0, so it basically takes off n time in time complexity. So what happens actually? When there is some list, let's suppose this is li is equal to 1, 2, 3, and I am writing li dot pop, and I am popping the 0th item. So it will remove this pop, it will pop this value 1, and it will shift 2, 3 to its new indexes. So what happens? It removes the first item from the list, then it shifts the other values to new position. So for that it creates new memory into the RAM, and it copy the next elements onto the new indexes. So this takes a lot of time. So instead of doing sorting in ascending order, we can just sort all the values in descending order. So such that we can use li.pop, and it will just return the last value. When returning the last value from the list, it doesn't take that much time. It just takes off 1. It just removes, it just put the pointer of last element here. So it will not take that much time. So instead of sorting in ascending order, we can just sort it in descending order, and instead of popping from the first index, we can just pop the last index. So I am just writing for sort reverse is equal to true. Both the solutions are correct, but we can instead of using pop of 0, we can use pop of -1. That is, -1 is the default value. I am again checking the conditions if it is working or not. Okay, it is working properly. Let us try to submit. Okay, this is also working fine. So this is the solution for 1329, sort the matrix diagonally. This is the medium level question, and it was pretty easy. Once you know how the primary diagonal elements works, you can just write it easily. Okay, this was all for this question. If you want, you can try another approach for the question. Not this question, you can change a question slightly. Instead of primary diagonal, you can write a code for secondary diagonal. That is, if it were asked something like this, 1, 1, 2, 2, something. So we are going like this for now. This is our primary diagonal. So instead of primary diagonal, you can go for secondary diagonal like this. You can try to write code for this. If you like this video, please subscribe to our channel and share it with your friends. This will help me make more creative content in the future. Thank you.